to analyze and produce three-dimensional images of the moon. What they did was send an orbiting satellite around the moon and take lots and lots of photographs of the moon, and then feed all those separate photographs and images into the computer, and the computer would produce a three-dimensional image of the moon. Well, the Shroud of Turin has always been controversial, so somebody came up with the bright idea of putting the Shroud of Turin under the VP8 image analyzing computer that NASA used. There's Dr. John Jackson, who's actually a former physics professor at the United States Air Force Academy. And this fascinating experiment was performed in 1976 by Dr. John Jackson, Dr. Eric Jumper, Reverend Dr. Kenneth Stevenson, Giles Charter, and Peter Schumacher. And they analyzed the Shroud of Turin with the VP8 image analyzing computer, and as you can see on the bottom right there, produced a three-dimensional image of the face of Jesus Christ, which actually makes it unique on the whole planet. There is no other two-dimensional image on the planet that will do this, because this shroud is dimensionally encoded. You see, the shroud is actually a three-dimensional topographical image. The closer the cloth was to the body, the more the image was highlighted, and the image then acts like a photographic negative with light and dark reverse, but dimensionally encoded. It's this dimensional encoding which is so unique, which is why I'm absolutely certain that the Shroud of Turin was not a fraud, because nobody can do this, even today, in 2009. On the left there, you can see the three-dimensional body of Jesus on the Shroud of Turin. Now, some people think that Leonardo da Vinci had a primitive camera called a camera occulta. Well, he may well have had that, but let me tell you that no camera today can produce these three-dimensional properties. Now we're going to look at carbon dating. The whole theory of the Shroud of Turin is medieval is based on radioactive carbon dating. And you need to know a little bit about carbon dating. You don't have to know a lot, you do have to know a little. Now there are 111 elements that we know about, and one of them is carbon. It's in position 6, and there are three types of carbon. There's the normal C12, which is normal carbon. Then there's two isotopes called C13 and C14. These are called isotopes. Now, radioactive C14 is actually formed high up in the stratosphere, and then is incorporated into carbon dioxide, drifts down onto the surface of the Earth, and then is breathed in by plants. We'll look at that. So radioactive C14 is formed in the upper atmosphere by the bombardment of nitrogen atoms with cosmic rays from the sun. We don't have to know the details of exactly how it all works, but let me just tell you very simply that this radioactive C14 is then incorporated into a gas called carbon dioxide. So a very small amount of CO2, or carbon dioxide, has radioactive C14 in it, which then drifts down through the various layers makes up the air, the surface above the Earth, drifts down to ground level and is incorporated using photosynthesis into the plants. So the plants then have radioactive C14 in them. And then, of course, we eat some plants, but animals also eat the plants, and of course we eat the animals and the plants. So both the plants and the animals and humans as well all have a small amount of C14 in them. Now, the whole basis of carbon dating is based on the radioactive decay. On the right-hand scale there, if you look, you can see the figure 16. So if you had 16 grams of C14, which you wouldn't have because we're only talking about tiny amounts, but if you came back after 5,730 years, only half of it would have decayed. In other words, it's not C14 anymore, it's decayed back to nitrogen. If you came back after another 5,730 years, you'll find there's only 4 grams of C14, and so on. And so the theory is that if you know how much C14 is in a piece of material, you can date it. Now, the shroud was made from flax. The Shroud of Turin is authentic and was manufactured at the time of Christ. And the linen in the shroud, manufactured around 33 AD, already had radioactive C14 in it because it's made from flax, which is plants, which has got radioactive C14 in it. So the shroud from the time of Christ had radioactive C14 in it. Now, this is very important. Carbon dating doesn't actually date anything. What happens is the people who interpret the results basically use the known rate of decay of C14, and using this known rate of decay, you can see in the British Museum that various specialists have said that the Shroud of Turin based on carbon dating is based 1260 to 1390. The AD 1260 to 1390 date was calculated by secular scientists who haven't taken into account the physics of the resurrection, and that's what we're going to be looking at. Now, this is very important to understand. It's not that complicated. According to carbon dating theory, if the shroud had very little radioactive C14 in it, the radioactive C14 must therefore have decayed, and it must be dated 33 AD. So on the right, they have a very pale shroud, which indicates that there's very little radioactive C14 in it. The glass is empty, and that would be a 33 AD shroud. But what they actually found was, on the right there, a very bright shroud, shall we say, indicating lots and lots of radioactivity. There's a glass half full to illustrate we're talking about lots and lots of radioactivity in this shroud, and therefore they say that according to the laws of carbon dating, it must be medieval, and maybe, they haven't actually said, but a lot of people say that Leonardo da Vinci created the shroud. So just to go through that once again, a very pale shroud, very little radioactivity, it's all decayed, an empty glass, it's the 33 AD shroud. A 1325 AD shroud would be, on the right there, lots of radioactivity, lots of C14 present, therefore it must be medieval, therefore possibly Leonardo da Vinci or somebody else created it. I hope you can understand that. A pale shroud, 33 AD, very little radioactivity, lots of radioactivity, it's a medieval shroud, 1325. Now, Leonardo da Vinci couldn't have created the Shroud of Turin. He just couldn't, it's not possible. Now, Leonardo da Vinci was a supremely gifted Renaissance artist, designer, scientist, engineer, and thinker, and many people believe he created the Shroud of Turin. Barry Schwartz, the official Shroud of Turin photographer, has publicly stated that the Shroud of Turin could not be created by the cleverest scientists in the world today. In fact, I've said earlier, it would be easier for Leonardo da Vinci to have designed and launched the Hubble Space Telescope, which was actually launched in 1990. Now, NASA planned the work on the Hubble Space Telescope in 1970, and my point is this: the technology is now available for Leonardo da Vinci to create a Hubble Space Telescope. But the laser technology is not available today in 2009 for Leonardo da Vinci or anybody else to create a Shroud of Turin, because nobody's got that technology. So nobody can create a fake Shroud of Turin in 2009. So I want to now issue a challenge for all the Shroud of Turin skeptics, of which there are many out there, because most people think the Shroud of Turin is a fraud. Before you start, let me remind you of the challenges you face to create a fraudulent Shroud of Turin. First, you need to obtain a 1st century piece of precious Jewish linen in a specific weave, 14 feet 3 inches long and 3 feet 7 inches wide exactly. This must exactly match the identical linen from Masada, Israel, woven in a specific way on a special ancient loom. Basically, this is unavailable according to Mechtild Fleury-Lemberg, a worldwide authority on ancient textiles. This piece of linen is very specific and must contain pollen from Jerusalem and calcium aragonite from ancient Jerusalem. And then you need to obtain not one but 2 different Roman leptons coins, both minted by Pontius Pilate in AD 29. Now, there are only 13 known specimens in the entire world of all 5 of the Pontius Pilate coins, but you need 2 more minted in AD 29. I'm going to say you're going to find that quite difficult to find 2 more. Then you've got to apply